Hello everybody, hope you're doing well. This is paper 2 from November 2023 and this is time zone 1. Now let's have a look at it and see what we can do. Last question and let's see what we can do. Alright, Mosaic Industries is an international company that sells cell phone cases. Their market research predicts that the average number of cases they will sell each month can be modeled by the equation. So number of cases that they'll sell can be modeled by this equation where X represents the selling price in euro of each case. So we have a function number of cases we sell as a function of the price per cases. A salesperson suggests that Mosaic Industries should sell their cases for 16 euros each. Find the average number of cases this model predicts Mosaic Industries will sell. So let's work this out. Number of cases is given by 20,000 minus 1,000 times the price per case. So this looks like it's just going to be an input-output kind of question. Our price per case was 16, so let's input that price of 16 and see how many cases. And it should give us 20,000 minus 16,000, give us 4,000 cases. Not too bad for a 2-mark question. Calculate Mosaic Industries' average monthly income before any expenses at the selling price. Okay, so income is total amount that the company would earn before expenses. Often we call this gross revenue. So income is going to be made up of, well, not just the number of cases. Total amount this company will earn that they will have flowing in as kind of gross revenue will be made up by the number of cases they sell multiplied by the price per case. And we know that they're going to sell 4,000 cases and they're going to sell them at 16 euros a piece. So 4,000 times 16, total income they earn is $64,000. So not too bad. Sometimes it's just a challenge interpreting what the question is asking and then formulating how to go about solving it. Total earnings, total revenue, number of cases times the price per case. Alright, so now we're getting into a little bit of heavier algebra. Hence, write down the function Rx, or revenue is a function of the sale price, I guess, that can be used to predict Mosaic Industries' average monthly income before expenses at any selling price. So let's go ahead and try to work that out. So we still have this formula right here. The income that they'll earn will still be made up of the number of cases times the price per case. So let's write out this equation. We're going to write out income as R of X. The number of cases that they'll sell is given by this formula right here. So let's substitute that. That's the number of cases. 20,000 minus 1,000x. That's the number of cases. And the price per case, well, they told us that X represents the selling price. And so this would just be equal to X. And that's it. It's not too bad. Okay, I think these are, I don't think this is the final question. I think there's some more further on. So not quite there yet. Mosaic Industries has 10,000 euros of fixed monthly operational costs. Additionally, Mosaic Industries must pay their phone case supplier 10 euros for each case. Calculate Mosaic Industries' average monthly profit if they sell each case at a price of 16 euros. So this is a 16, not generalized, but just 16. All right. So profit is equal to income, or gross revenue, minus the expenses that we need to pay. So this is often called net income, total take home, I suppose, after all expenses. And so Mosaic Industries' average monthly profit if they sell each case at a price of 16. So earlier on we had this question where we found out the income at $16 a case, and we found out it was $64,000 in income or gross revenue. So $64,000 $1,000. But we know they need to pay 10,000 euros in overhead cost, in warehousing or something like that. Maybe labor and so on. And we also know they need to pay 10 euros for each case. So 10 euros, and then how many cases were sold. So 10 euros for every single case. We sold 4,000 cases. So 10 euros times 4,000. All right. And then we can hope for Mosaic Industries that this is positive. So 64,000 minus 10,000 minus 40,000. And this will give us a value of $14,000. Okay. Show that the average monthly profit for any selling price x can be found by the function p of x is equal to negative 1,000 x squared plus 30,000 x minus 2010. Okay. So profit is still given by income minus expenses. And we do have a formula for profit already. Or sorry, for income rather. The generalized form for income is $20,000 minus 1,000x times x. That was how much gross revenue. $20,000 minus 1,000x times x. That was what we had up here. This revenue that they earn. Okay. They're still going to need to pay $10,000, and the other expense is going to be the number of phone cases, or sorry, the price per case, which is $10. Selling price X can be found by, and then the number of cases that will sell. So the number of cases that will sell. How could we write that out? Okay. This is the number of cases is actually just given by this right here. This is our number of cases. So we can write that just as 20,000 minus 1,000x. Okay. And that looks to be it, actually. So how many marks is this question? It's just a 2-mark question, actually. If you wanted to be absolutely sure that this whole long expression turned into this, you'd need to expand it. And actually I'll expand it right now, but if you're not sure how to expand it, this is just distribution. So if we have x times, let's say, 20,000 minus 1,000x, what we would do is we would multiply the term out in front by every term on the inside. So x by 20,000 would give us 20,000x, and this would give x times 1,000x, would just give us 1,000x squared. And then we can do that for all of these. So x times 1,000, or negative 1,000, x times 20,000. This becomes what we found out before, 20,000x minus 1,000x squared, still minus 10,000, and then we're going to multiply once again. This is going to be, in this case, 20,000 times negative 10. It's going to be 200,000. Got to be careful here. This is negative 10 times 20,000. This is negative 10 times negative, so this is actually going to turn into a positive 10,000x. Okay, so let's go ahead and get our x squareds. This is negative 1,000x squared, are just plain x's. So there's an x, there's an x. We're going to have 20,000 plus 10,000, or, whoops, 30,000x. And then we have 200,000 plus 10,000, or sorry, negative 200,000 minus another 10,000 would be subtracting a whole $210,000. And there it is. Okay. If that one was a little challenging, remember we have kind of discrete parts of a paper too, so even if this one was a little confusing, question F, or part F, is kind of encapsulated in itself. So here they're asking us for part F to find p prime of x, or the derivative. This prime, remember, is the derivative. So let's find p prime of x. So we know that p of x is equal to negative 1000x squared plus 30,000x minus 210,000. In your formula booklet, you have the derivative. So if we have some function f of x and it equals some variable raised to the power of n, f prime of x, or the derivative, what does it require us to do? We take the exponent, multiply it out in front, so then it would become nx, and then we reduce the exponent by 1, n minus 1. And that's in your formula booklet. So let's go ahead and apply that here. This is x raised to the power of 2. Let's multiply out in front, and then we have negative 2,000. X used to be squared, now it's just to the power of 1. Whenever we have an x, the x's just go away. You can think of it as x to the 1, and it's used up its only power in some sense. And now it's x to the 0, and anything to the power of 0 just becomes 1. So now we just have plus 30,000. And constants themselves just go away. So this would become 0. Alright. That looks good. That is our derivative. Show that the salesperson's selling price does not maximize their average monthly profit. Okay, so 2 parts to this question. It doesn't ask you to make use of the derivative. Sorry, I should put a prime there. It doesn't ask you to make use of the derivative. Nope, I'm sorry, there should be a prime here. So we can actually just graph this function. But if we wanted to use the derivative itself, it's not too bad actually. So let me just provide a little bit of conceptual background. So if our original function looks like this, our derivative is also called our slope function, and what it'll do is it'll find the slope of the function at any given point. So the slope of the tangent line. So if we want to find the slope at this given point, it'd be something like this, except it wouldn't be curved. It'd be something like this. And if we wanted to find the slope at this point, be something like this. And then after if we wanted to find, let's say, this point right here, it would be something like this. And if we wanted to find the slope of the line at this point, that would be what our gradient function, our derivative, would do for us. And we see we're having increasing slope, increasing slope, increasing slope, but there's going to be one point on this function where we move from increasing to decreasing, and that's going to be a point where we have a slope of 0, and that's going to be where p prime of x, where the derivative itself is equal to 0. So after we're done increasing, before we start decreasing again, there's going to be a point where it's exactly flat. And so to solve this part 2 right here, just using the derivative, we could just say, okay, well, what's the point where p prime of x is equal to 0? Or when does this whole derivative equal 0? And you can solve it that way. But if you want, you could also just graph the original function right here and find the maximum. For visual sake, I'm actually going to graph it, and that's how we'll solve it. Okay, so let's go to the calculator screen and let's graph the original function. This menu, haven't needed to use this at all actually for this exam, which is a little surprising. Negative 1000x squared plus 30,000x minus 210,000. 1000x plus 30,000x minus 210,000. This is going to be very, very large. So let's hope that ZoomFit will help. And it's not actually too bad at all. ZoomFit doesn't too bad. Doesn't do too poorly. Let's zoom out a little more. And that's not bad. I think, whoops. I think we can do everything that we really need to just with this. We could change the bounds a little, but I think it's okay. Let's find the max. Analyze graph, maximum, and there it is. So once we sell once we price the phone cases at $15, we have a maximum profit. And we'll explain what this is, or this 1.5 E plus 4. So let's go back to the original document for a sec and find the maximum. So I'm going to put the graph underneath again. And this actually would count for process. They would want to see a sketch. And here's our function right here. Here's our maximum point. And our calculator gave us this, 1.5 E plus 4. And that's not really acceptable for the IB, or they wouldn't really like that. So what is this 1.5 E plus 4? This E is just times 10, and then this 4 is to the 10th power. So when we see 1.5 E to the 4, what this is saying is 1.5 times 10 to the 4. Or, if we have 1.5, let's move 1, 2, 3, 4 hops. So they earn $15,000 in gross profit. Profit as a function of the price of a phone. And there it is. So we'd want to change this if we wanted to write this as process marks. So let's just say 1.5 times 10 to the 4. So how can we show that the salesperson's selling price does not maximize their average monthly profit? Well, we saw that the maximum profit occurs when we price our phones at $15. Alright. Final 2 questions, and I'd imagine this should be a good challenge. Mosaic Industries negotiates a new deal with their phone case supplier. Under the new deal, the supplier agrees to discount the cost of each case based on the number of cases purchased by Mosaic Industries. The cost charged by the supplier for each case can be found using the function. So cost as a function of the number of cases is equal to $10, but now we are subtracting a fraction of a cent for the total number of cases. Or sorry, the total number of cases, where N represents the number of cases sold by Mosaic Industries. Find the function that can be used to find Mosaic Industries' average monthly profit using the new deal from the supplier. So average monthly profit using the new deal from the supplier. Okay. So what was our profit function before? It used to look like this. And it was, I'm going to use a different color here. This was, this was the income before. This was just the overhead cost, like the warehouse, the kind of, the base kind of overhead cost that we needed to pay, or that Mosaic needed to pay. And this was the cost per phone. And this was the number of cases. And so our cost is no longer $10. Actually, I'm going to grab this. Hopefully it'll grab just this part. Okay, and we'll copy this. And we'll edit it down here. Okay. Clean it up just a little. So this is still much the same. But we're going to change just parts of this. So profit, this is still the same. This is their income. This is the fixed costs. This is the fixed cost, the overhead. And then they had this final value. And this, remember, was the cost per case. And this right here, I'm going to clean it up. This was equal to the number of cases. And so the only thing that's changed is that the cost per case is no longer $10. It's 10 minus 0.001 n. Income that we make is still the same. It's number of cases times the price per case. Fixed cost remains fixed, but the cost per case now changes. So I think there's more complicated ways to work this out, but otherwise I see it this being the most straightforward way. 20,000 minus 1,000x times x minus 1,000 minus, now our cost per case is $10 minus 0.0001, and then n is the number of cases. N is the number of cases. This is what our number of cases is. It's given by, it's getting a little cluttered, I apologize. This is the number of cases. So $10 minus, good question. $10 minus 0.0001 times the number of cases, which is given by 20,000 minus 1,000x. So that's a good challenge. 0.001 times 20,000 minus 1,000. Geez. 1,000x. That's the cost per case. $10 minus $10 minus, this is the cost per case. The cost per case is $10 minus 0.001, 20,000 minus 10x. And this is the number of cases. So really running out of space here. 1,000x. Okay. Wow. Here is the income. This is number of cases, price per case, fixed costs, minus right here the cost per case. And it's $10 minus a fraction of a cent for every single case that they sell. And this is times the number of cases. Wow. Okay. All right. I mean, sure. It's a good question. It's a good question. There it is. I think potentially it's possible to simplify things a little, especially up here when we substitute this 10 minus 0.001 times 20,000. We could simplify that because 10 minus 0.001 times 20,000 would just be 2, and 0.001 times negative 1,000, negative times a negative would be positive, and this would be just 0.1x. So if we just multiply this value times this value, and then that again simplifies, 10 minus 2 is 8 plus 0.1x, and this would be the cost per case. So, I mean, this last question has taken quite a while. We could rewrite this if we wanted to. 20,000 minus 1,000x times x minus 10,000 minus, and this is our cost per case, 8 plus 0.1x cost per case times the number of cases. And I guess it doesn't look as bad where that, it still looks pretty bad, but as intimidating. Okay. Find the function that can be used to find Mosaic's average monthly profit using the new deal. And there it is. We're good. By the way, we can leave it like this. Just looking at the mark scheme on, I'll bring it up actually. here? Here it is. Here's the mark scheme. We can leave it just as that. We don't need to expand and then write it in some clean form. It looks like the IB or examiners will accept this value right here. Okay, so let's return to the main document that we're editing right now and go on to H. H says, hence find the selling price per case that Mosaic Industries should choose in order to maximize their average monthly profit under the new deal. Okay, so in this case you might want to simplify it because this is going to be a lot to put in the calculator. I'm actually going to do it. I'm going to multiply it out just to see how you can possibly do it. Again, we'd want to expand. And so this would be, I'm just going to work this out as quick as I can, I suppose. 20,000 x minus 1,000 x squared. This is still minus 10,000. And then we have what's called binomials. So we need to multiply this by this and this by this. So 8 times 20,000. Ooh, I'm starting to have second thoughts here. 8 times 20,000 would be 160,000. 8 times negative 1,000 is going to be negative 8,000 x. This is going to be 20,000 would just be plus 2,000 x. So right now multiplying 0.1 times 20,000, 0.1x times 20,000. And then 0.1x, and this would be negative 100x. Since there's a negative out in front, right here, it would turn everything to a positive. So what I'm actually going to do is just remove the brackets. To save some time, I'm going to remove the brackets, and everything that was a positive, I'm going to turn to a negative, and everything that was negative, I'm going to turn to positive. Now we got a group like terms. If you're still around watching this part, negative 1,000 x squared. Now we have our x's. 6,000, this would be 26,000 x. And the last little bit, negative 16,000 plus 10,000 would be negative 170,000. Alright. To find the maximum selling price under the new deal, this is our profit. Let's graph this function and solve. Okay. Gonna get a new screen. Let's go into add graphs. Let's, I was almost tempted to use the original one just to see if it would work. I'm wondering if it will. 200,000. Actually, we did all that expansion. Let's go back. 1,000 x squared plus 26,000 x minus 170,000. 1,000 x, 26,000 x. Good. Let's go ahead and hopefully zoom fit will work. That's not bad again. And it just looks like potentially, I hope nothing has gone wrong, but let's see. Zoom in. Let's see if I entered this incorrectly. Negative 1,000 x squared plus 26,000 x minus 170,000. Let's see. Okay, let's find the maximum. Oh, hence find the selling price per case that Mosaic Industries should choose in order to maximize their average profit. Okay, let's find the maximum. Analyze graph. Maximum, what is it? No, this can't be right. This says that they're losing money under this new deal, but that doesn't make sense. Let's see. I see. Okay. So it looks like something went wrong in the addition. So let's go back to the document. Okay. So we had, this is where it is. We had negative 1000x squared. And then, okay. So, I mean, kind of tricky. When we multiply this 0.1x by negative 1000, it comes to 100x squared. And if we have positive 100x squared and negative 1000x squared, altogether we have negative 900x squared. So once again, 1000x squared expanding 0.1x times 1000, negative 1000x squared, gives us this negative times a negative turns into a positive. Positive 1000x squared, positive 100x squared minus 1000x squared gives us 900x squared. So let's go back to the document. Let's edit this and write this as 900. And there we go. There's our new max, 14.4. So I'm gonna go back to the document just about there. Profit as a function of selling price. Again, we get a quadratic. Here's our maximum, and it says 14.4. And when that happens, we have 1.78 times 10 to the 4, or 1, 2, 3, 4, roughly $17,800. And this should be all right as a process right here. Find the selling price per case that they should choose to maximize their average monthly profit. 14.4 to get $17,800. All right, everybody. I hope that was helpful, and as always, best of luck. Take care.